Hello everyone, I hope you are doing well. So in the previous video we learned about dictionary. Since dictionary is very important data structure, and if you have any difficulties in a dictionary, please comment out. I'll try to solve each and one of them. It's very important. Okay, you need to know dictionary as you are moving forward in Python. Today we'll be learning about simple yet very useful functionality in Python that are operators and expression. We have learned about it here and there, but today we'll be dedicating this only to operator and expression. So let's get started. The first topic will be like what are operators. So in simple terms, if you are saying what are operators, operators are special keyword. Okay, operators are special keyword that allows you to perform various functionality. Okay, that allows you to perform various operations. Operations. Okay, so if in simple term we want to say what are operators, operators are special keyword in Python that allows you to perform various operations in values and variable. Okay, in variables and values. So that is what in simple term what an operators are. Operators are special keyword that allows you to perform. If I show you an example, then you will know what operators are. So we have already learned about plus, minus, equals, right? Those are some of the operators that are used in Python. Okay, so in a basic if you want to go in a one line, so it's an operator has special keyword that allows you to perform various function or operations in variables and values. So that is what operator. An example of operator will be like plus, minus, equals, and we learned about power symbol, and we learned about double equal. All of those are operators. Okay, now let's learn in putting them in a category, so that when we hear about the category we know that what we are talking about. So what are the various category that we can divide? So we can divide into arithmetic. So in the arithmetic, what will be coming? We'll be getting like plus, minus, multiplication, division, and all that. So that is one. Second, we can divide into comparison. So comparison, as the name say, when we want to compare between variables, so we can use is it equal, is it greater, is it less, so something like that. Then we may see like then we can go logical operator, like when we use like and or, right? Those are logical operator. We can use logical, then we can use and or, something like this. Then we have learned about how we can assign a variable, right? When you say x equals to 5, we are assigning 5 to x. So those are type of assignment variable, assignment operator. So we can say this will be like equals. When I do plus equal, when we saw, right, when we increase a number by 1, we do plus equal and something like this. Then we can say bitwise. We haven't heard of bitwise, but we'll be knowing about bitwise. Bitwise is you know that a number in a computer understand in the form of binary. So we can perform binary action operation also, that is called bitwise, where we perform bit by bit of all that up. When you express in binary, we get each and every bit of that number, right? How we can perform operation among that bit. So we'll be learning something about how and is work, how or works, and something like this. Then comes our membership. So membership is like when we learned about arrays, right? Suppose we wanted to know if a number is part of that array, then we can use like is, means we can use something like in, and if it's not in, so something like this. And then comes our identity operator. Identity operators. In identity operator, we can say like if both of the objects belong to same reference id, or both of the objects, like, or both of the values, are they located in the same memory, are they referencing the same thing? We saw this in when we wanted to copy a list, right? We saw that. So that is where the identity operators come into play. So these are the some of the roughly categorized operators that we'll be learning today. We'll be learning arithmetic, comparison, logical, assignment, bitwise, membership, and identity. Now let's go through them one by one. Let's start with arithmetic. Okay, so let me remove this and put the arithmetic operator in the first place. So we'll be learning about arithmetic. So first arithmetic is, let's do addition. So addition is simple. You know how addition works. We use the plus symbol. So let's take two variable. Okay, let's say x equals to 5 and y equals to 10. So these are two variables. Now let's not put addition, let's do one by one, everything will be doing. Then what are the arithmetic operators that we can do? We can do like plus, we can say x plus y. Then we can do x, let's print this so that we know it's working. So we'll do python 09 operation. So you can see it prints 15. Why? 10 plus 5 is 15. Then there is minus, then you can do x minus y. Now here x is greater than y, right? 5 is less than 10. So when we do minus of this, we should be getting it in negative numbers. So let's run this and see. Yes, we get minus 5 since 10 is greater than 5, right? So when we divide 10 from 5, when we remove 10 from 5, we'll be getting minus 5. Then there is multiplication. So you can do x cross y. So what does x cross y print? It will 10 into 5. 10 into 5 is 50. So you'll be getting something like 50. Then we have they're called division. You can do print. Let's do y by 5 so that we get the proper answer. Y by x. So now y by x, 10 divided by 5 is what? 2. We'll be getting 2.0. We have already learned that when we divide a number in Python, we'll be getting in float. So if you wanted to get in the number, it's say you want only 2 to be coming, then you can do something like print y and put the division symbol 2 times. It's float division. Okay, so it will take only the number, it will remove the decimal part of it. So now if you run this, see, you'll be getting only the 2. Then there is one more called when you do power. So you can do print. You can do let's not use this x and y since this will be too large of a number. Let's do 2. Put the power symbol, the double star and 3. So what this will do is it will multiply 2 3 times. So when you multiply 2 3 times, what is the answer you'll get? 2 cross 2 is 4, 4 cross 2 is 8. Now if you run this, see, you should be getting something like 8. So that is how power works. So this is addition, and this is subtraction, this is multiplication, this is division, this is float division. So float division is when we wanted to get the initial, not the after decimal. So it will take the lowest number that it can get. Suppose if it's 2.5, it will still go to 2. So this is floor, FLOOR, float division. Then this is the power of a number. Okay, so that is what arithmetic operations are. I have you understood how arithmetic operation works. So these are some of the operators that you can use using arithmetic. So let's comment out all of this and let's go to the second operator, that are comparison operator. Comparison operator, what they do is it compares two values. So it compares two values. So when we compare two values, what are the possibility? Either they can be equal, they can be greater, it may not be equal, it may be less than equal. So those are the comparison operator. Let's go through them one by one. So let's do one more time. X equals to 5, y equals to 10. So now you know here x is less than 10. So how you can say in Python, you can say print x is less than y. So as how you do in mathematics, right? Similarly, you put this angle bracket and say x less than y. So now this will give you a result in true and false. So now if you run this, see, you get the answer in true. Why? Because we know x is less than y. Here x means 5 and y means 10, right? So 5 is less than y. So it gives true. Second time, when you do print x is greater than y. Now you know x is 5 and y is 10. So x cannot be greater than y. So this should give false. So now if you run, see, the second one will be false. Same like this, a number can be less than or equal, right? Suppose if, let's put a z here, z is equal to 5. Here x and z are equal, right? So you can compare like, is x, you can say x less than equals to z. So here what we are saying, is x less, means suppose here z is 5, right? So x is 5, so x is not less than, but it is equal, right? So you can do both at the same time. Is it less than or equal? So it will follow both the condition. If it's less or equal, for both conditions it will return true. This will return true. If you see the last one, this will return true because it's not less but it's equal. Similarly, you can do print is x greater than equal y. So now what will be the answer of this? Take a second and pause the video and see what you can, if you can verify, like, is x greater or equals to y. So first it will take x. Here x is 5 and y is 10. Is x greater than, if 5 greater than 10? No. Then it will check, is 5 equals to 10? No. So since both are false, it will give you a false. If you see the last one, it is false. So this is less than, greater than, Now there are two more operators, is it equal. So now we can do x equals to y. Now this will check the equality of two of them. Is it completely equal, like 5 equals to 5, that will be true. But here x equals to 5 and y equals to 10. Now if you run this is not equal, right? So you'll get the answer in false. So as like equal, there is also one operator called not equal. X, put this exclamatory sign and equals y. So what this will say, x is not equals to y. Here we know x is not equals to y, so this should return you the true. If you run this, you see the last one is true. So this is how you can validate among 2 or 3 variables where we wanted to say if it's greater than, equals, less than equal, greater than equal, or not equal. So these are some of the comparison operators. I hope you got this. Let's write here, this is less than, and this should be greater than, then this is less than equal. So let's comment this out, and it's a less than or equals. So first it will check if it is less. If it is not, then it will check for equal. If any of this condition meets true, then it will return true. And this is greater than or equal, then this is equals, and this is not equals. Okay, so these are some of the comparison operator in Python. So I hope you got this. Now let's go to the next operators, that is called logical operator. Logical operators are where you use logical, like when you use logical term, you know that what you are comparing is this and this, or this or this, and you should be getting true and false based upon that. Okay, so let's create two more variables here, x equals to 0 and y equals to 1. Okay, now let's print x and y. So how this works is, this AND operator will check if x and y both are true. If it's both are true, then it will return true. If any of them are false, then it will return false. Now let's see what it prints. If you see, it prints 0. Here 0 means false. Okay, so if it means false, then you know here, then why did it print false? Since I said 0 means false, right? So this, when you say x equals to 0, this means x equals to false. So in Python, right, if 0 means false and any number other than 0 is true, so this means true. Similarly, how you can use that directly also, a equals to true and b equals to false. You can use something like this also. But if you use number, then remember that 0 means false and 1 means true. And similarly, you can do like print a and b. So both of them should be giving false. Why? Because for both of them, 1 is false. So in the second case, b is false, and here x equals to 0 means false. So both of them should be giving 0, 0 as the answer. If you see, since a and b both are in the boolean way, right, true and false, so it's giving false. But when it comes to integer way, it gives 0. But both of them means the same thing. So 0 means false here, and here false means false. Now if you do a true condition, if you do print a or b, so other than and, in or what it does is, if anyone is true, among a and b, if anyone is true, then it will be true. So now if you run this, see, you'll be getting true. Even though b is false, you'll be getting true, because when it comes to or, if any one of them are true, then it is true. Now there is one more operator called not. We learned about if else clause, right? So suppose if you say if, here we say if x, so what do you think this will print? Present, else, print, absent. So what do you think this will print? Take a pause and see this. Okay, so here let's see what it prints. It prints absent. But why is it so? We know x is a number, so it should be present. As I said here, when it is 0, right, 0 by definition on Python is false. So here, if false, then this will not work, so else will come into place. Similarly, it will say like this. Now there is one more operator, is not. Not means if you want to change this true to false. If it's not 0, means that means if it's true. So now if you run this, see, you get present. Why? because we are just changing the value of x here. So by default value is 0. Now we are saying not 0. What is not 0? If a number is 0 and you are saying not 0, that means it's 1, right? So that's how it works. You can use this not operator here. So these are the three logical operators that you can use. You can use AND. When both of them are true, it will return true, and if any one of them are false, it will return false. And here in Python, 0 by default means it's false, and you can use one more operator called OR. In OR, if any one of them are true, then it will be true, but in AND, both of them needs to be true. If any one of them is false, then it's false. And there is one more is not. When you wanted to check if it's not this, if it's not this, just it means like you're reversing what you wanted to say. That's how it works. This example should fulfill you what not means. Okay, let's comment out this. Let's go to the second one, that is assignment operator. Assignment operator, we are using it every time, even though we use today also. Take a pause and see if you can figure out where we use assignment operator. So assignment means when we assign a variable. Suppose we said here x equals to 10, right? This is assignment operator. Why? Because we are assigning a value of 10 to x, right? This equal symbol here, this is not equality. Equality means double equal. So we learned in the arithmetic, in the logical operation, like equality means double equal. But when you use single equal, it means you're assigning a value to something. Here you're assigning a value of 10 to x. Now when you print x, it should give you 10. Why? Because we assigned a value of 10 to x. It gives 10. Why? Because we are assigning, and we have done this multiple times. This is our 9th lecture. So up to now we have always used this variable assignment. So this is part of the assignment operator. Now along with this, there are many things we can use. Like if you want to increase this 10 by 5, right? What you can do is x equals to x plus 5. This is one way of doing it. Now if you print this, this should give you a 15. So it does not make sense in general mathematics when you say, but here it will make sense because it will say whatever the value of x was, plus this to 10 and put the value back to x. So this should print you something called 15. So now if you print this, it should print something like, you see, first it was 10, then it went 15. But in Python, you don't need to write this long. You don't write x equals to x plus 5. What you can do, you can use this assignment operator using positive plus assignment operator. You can do x plus equals to 5. So what this will do, this is similar to how this works. It's exact same. So what it will take x and it will add 5 to the value of x. So now if you print this x, right, you have to print x. I have already talked this once in our previous lecture, but still let's see this and run this. See, you still get 15. So when you wanted to add something to a number to itself, you don't have to write this long way. You can just use plus equals to 5. And it does not just stop on plus. You can use any operator, any arithmetic operator. So you can use x minus equals to 5. And if you print x now, so here you should get back the 10 value again. So first is 15, now with negative 5, so it came back to 5. Then you can do cross equal, so you can do cross equals 5. Now what will this print? It will be 10 cross 5. 10 cross 5 is 50. If you run this, you'll be getting 50. See, you get 50 here. So this is how you can use this assignment operator. There is division, there is multiplication. I want this, you should do it. So there is division, there is flow division, there is power. Do this for your homework, okay? Just see how it works. If it does not work, put it in the comment. I'll just solve it. So you need to do this, how you can reassign using division, flow division and power. Do it in the same way and see how the result changes. So that was it about assignment operator. Let's go to our next operator. These are bitwise operator. So to understand bitwise operator, right, so you need to have a little bit of general knowledge about how binary number works. So in binary, 1 means 0 0 if you are taking 2 bit at the time, and 2 means, okay, not 1. If 0 means 00, 1 second, 0 means 00, 1 means 0 1, 2 means 10, 3 means 11, and 4 means 100. Like this it goes on going. So if you wanted to know what is the binary number, how to get binary number, what you can do in Python, you can do something like print bin, that is binary of a number, suppose 4. Now if you run this, see, you'll be getting something like this. Here you just ignore the 0 and b. If you want to ignore it directly, you can use this slicing operator when you can remove 2 and run this. So you will be getting the binary of a number. So binary of a 4 is 10. So that is how you can get binary. So in bitwise operator, let's learn about, first we'll learn about AND operator. Okay, so first we'll learn about AND. How does AND works? AND is like how I said in the previous when we learned about logical, right? It will take 2 bit and we'll do the AND operator among them and say what the result is. So let's do one thing. Let's do x equals to 4 and y equals to 5. First let's print what is the binary of 4 and 5. Binary of 4 equals to binary of 4, take out the 2 part of it, and similarly we'll do binary of 5. Okay, we'll do binary of 4 and binary of 5, and let's print this. Print binary of 4 and print binary of 5. Let's print this too and see what we get. So we get 100 and 101. Now when we do bitwise operator, right, if you do print x and y, here what we are doing an AND operator between x and y, but in the bitwise format. What we get the answer, let's see. We get the answer as 4, but why is it so? So how this works is, here we know that binary of 4 is 100, right, 100, and binary of 5 is 101. And I said here how it works in Python is, so here 0 means false, 1 means true, and in the AND operator we know that AND means where if any one of them are false, then it's false. Okay, so now this is false, the 0 at the end, start from the end. Okay, start from the right hand side, end of it. So here 0 is false and down 1 is true, and we know 0 false and true means false, so it's 0. For the second one, it's false and false, false and false makes false, false and false makes false, and the first one is true here, and the second is also true, true and true is true. This is 100. Now we know what is the 100 binary form of, binary of 4 is also 100. That is why you get here answer is 4, because when we do a binary operation by ourselves, we get 100, and 4 means 100 in binary. So that is how you can do AND operator in Python. So how it works, it will take the binary of both of them and just do an AND operator from the bit, and the counting will start from the right hand side. That is, first it will do this 0 and this 1, then it will go to the second one, then it will go to this third one. So that is how AND operator works. So similarly like this, there is also OR. So for OR, how it is, it's like print x. For OR we use that line pipe operator, x cross x or y. Now if you run this, you see you get 5. So let me comment out the previous one. Let's print previous one and let's run this once again. So you get 5. Why did you get 5? So let's come back to this operation once again. Now this is an OR operation. So in OR operation, how it works is, if any one of them are true, then it's true. So let's go to the last bit. 0 is false, but here 1 is true, so this will be true. Now this is false, false and false is false. Now here true and true is true. Now it's 101, and we know the 101 in binary means 5 in our integer number, so that's why we get here 5. So how does OR works is, if any one is true, the result is true. Okay, and here if any one is false, the result is false. So that is how this AND and OR works. Now there is one more called XOR operator. So let's do it. So XOR operator works like print x and this power symbol, x power y. So how this works is, if both are same, then it's false, else true. If both of them are same, then it's false. Now here, are both of them same for the last bit? Okay, always start from the right hand side end. Are both of them are same? No, that means it's true. True means what? 1. Now for this, are both of them same? 0 and 0? Yes, so it's 0. Are both 1 and 1 same? Yes, so it's 0 again. So now we get 0 0 1, and we know the binary of 1 is 1, so that's why we get the answer is 1 here. So that is how XOR operator works. Okay, so 0 and 1 is 0, 0 0 0 1 1 is. So let's do one thing. Let's copy this and put it in every side, so that when you see this you don't get confused. Okay, so 0 and 1 is 1 for OR. 0 and 1 means 1 0 0 0, and this is 1. And for JOR, how does it work? It works like, if any one of them are, if both of them are different, then it's true, else it's false. So this is how JOR works. I hope you got that. So these are some of the, there is 2 more. Okay, left shift and right shift. So let me show you what left and right shift means. First let's learn about left shift. The operator that we use in left shift is this one. Okay, use double angle sign, less than double angle sign on the left, going means that is pointing toward the left side. And how this works is, suppose z is equals to 4, and we know 4 in binary means 1 0 0. So when you use z shift in the right, so what you can do is, you can write print z, go to the right by how many bit you need to say, by 1 bit. Suppose we said 1 bit, you can put here any number. Okay, so what this will do is, it will take this number, first is 100. Okay, so this is 4, then it will just push it 1 bit to the right hand side and will extend it by using 1 0. So now it pushed by, means this were 3 bits. Okay, initially there were 3 bits. Now it will add 1 extra bit to the end, that is, it is pushing to the right hand side, pushing to the left hand side. This number is pushing left hand side and extending using a 0. So now when you print this, you should be getting something called 8. But why did you get 8? Because if you run this, print binary of 8, and run this, see, you'll be getting 1000. And see, we also got here 1000. So that is how left shift works. So it will shift the binary number by 1 bit, and it will put a 0 at the end of it. So now if you do by, you can change this number. Okay, now if you do by 2 bit, suppose you don't want to go by 1 bit, 2 bit, so it will add 2 more zeros at the end of it. So now when you run this, see, it printed 16, and we know if you run here 16, and run this, see, it added 1 and 1 2 3 4 zeros, and see here it added 1 and 4 zeros. So that is how left shift work, not shift, it's shift, SHIFT. And there is one more called right shift. Right shift, same here with the angle braces, but this time it's pointing to the right. So this works same how left shift work, but here we are removing 1 bit from the number. Suppose this was z equals to 4. Okay, and we know 4 means 100. So now if you do print of z to the right by 1 bit, 1 bit means it will reduce by 1 number. So now what it will do is, it will take 4 and it will remove 1, because it went to the right and cancelling 1 bit. Now if you print this, you should be getting 2. See, you get answer as 2. Let me run one more time. So you get answer as 2. Why? Because if you run one more time here, binary print binary of 2, and run this, see, binary of 2 is 10. And when we shifted 100 by 1 bit to the right by removing 1 bit at the end, then we get 10. Now if you do by 2 bit, you can do by any bit when you say here, but when you get 2 bit, then 2 zeros will be removed. So earlier there was 2 zeros, now this 2 zeros will be removed, so it's 1. Now if you run this and see, it should give you answer of 1. See, you get the answer as 1 because the binary of 1 is 1. So that is how it works on the bitwise operator. We have AND, OR, and we have left shift and right shift. So that is how left shift and right shift work. Why am I writing shift every time? It's not shift, it's shift. Okay, now let's come to the last second, so that is membership operator. Membership operator means if we wanted to say if a number is part of it. So we have learned about string, right? So we'll write let's one string means let's say let's code together. So this is one string, right? Now if you wanted to say is C part of this S, what you can say, print C in S. So what it will do is it will check if C is in S. We have done this when using range, right? When we say for I in range. So what this in does, it will check one by one everything in a linear way, that will go one number at a time. Here also it will check if C is part of it. So it will go through L, E, T, S. When it finds C, but this C is not equals to this C, so it will just keep on going until it finds C. Now let's run this and print. See, it gives okay. Let's comment out here this one and run this one more. See, you get false. Why did you get false even though C is there? So here you need to be that it's case sensitive also. So let's print one more time. Print. Now let's say if L part of it, L in S. Now if you run this, see, first it printed false because C is not part, but L is part of this S, right? So it printed true. That is how you can say if a number is in a string or in a list, right? You can use this in operator. So you can use for what is a list also. Suppose L is equals to 1. Mostly you'll be using it in list. So 1, 2, 5. So you can say print 1 in L. Is 1 part of L? We know 1 is part of L. So it will print you true. Then as like in, there is also one called not in. So we can say 5 not in L. Now we know 5 is in L. So when you say not in L, that means it's saying that I said 5 is not in L, and you know that is false. So this will give you false because we know 5 is in L. So this is how you can use in and not in. This is how to check if in a sequence, right? If something is present in sequence or not present. So that is how you can use in and not in. So these are part of membership operator. Okay, let's comment this out. Now let's go to the last one. This is very, very important. And I think we talked about it when we talked about list. In list, when we are doing about copying and all that, at that time I mentioned this once. So if you haven't watched the list, watch list. List is very important. Then watch the dictionary. Dictionary is very, very important. And let's see about how this identity operator works. So what identity operator does, it checks if both of them reference to the same thing in the memory variable. So let's create a list called L1 equals to 1, 2, 3. Let's create L2 equals to 1, 2, 3. So now let's print L1 equals L2. What do you think this will print? So this is the arithmetic operator that we learned when we use logical, right? If it's equal. So now here L is 1, 2, 3. L2 is 1, 2, 3. So is it same? Yes, it is same, right? So it's printing true. Similarly, like equals, there is one operator called is. Print L1 is L2. From outside, what do you think this will turn into? Is it true and false? True or false? If you run this, see, this is false. So it does not only check the values of it. It's not dependent on what the values. It will check are they part of the same memory. But we said in Python, all the new variables, right? They are part of different memory location. So they are not same. But if you do here L3 is equals to L2. I said when we are learning list, when we assign a list to other list, it is actually referencing to the same memory. And if you change L3, then L2 will also change, and vice versa. If you change L2, L3 will also change. But now if you run this, print L2 is L3 and run this, see, it prints true. Why? Because here they're referencing the same memory location. Both L2 and L3 are referencing the same memory location. That is why it's printing true. So how is different from double equal is? Double equal checks only if the value is same. Here the value is same, but they are printing to two different array lists, right? They're not in the same. They're not the same array list. Means it's not same in the memory. So that is how is and double equal is different. So this is very useful when someone asks you like why they are not equal. You can say in double equal it looks only for value, looks for value. And this, when you say is, right, it looks for reference or memory location. So it looks for memory location. Are they part of the same memory? Are we saying, are they same because they exist in the memory location, or by value? If it's by value, then we can figure it by double equal. But if you say by memory location, then we can figure out using is. When we learn about object oriented, right, from the next class, not next class, it will take some time because we did not learn about function. We'll learn function, then we'll go to class, then this is operator will come very useful. So there is one interesting thing is, suppose let's say a equals to 10, b equals to 10. Here both are equal, so you don't have any doubts. So I'll do a double equals to b, a double equals to b, and let's print this. See, it's true. But if you do a is b, still it gives true. But as I said, when you do two variables, right, they're not on the same memory location because we did not copy it, but still it gives true. Why? So there is a special case. What Python does is, Python stores integer from -5 to 256 in cache. So what this does is, Python stores this number from -5 to -256, right, in cache. So every time we are referencing it, it is actually referencing to that memory location itself. So this will always give you yes. But if you change here, suppose we write c equals to, okay, let's do one more thing. Let's copy this one. So let's create two more variable, d equals to 500, e equals to 500. So this by default, when you do by equals, right, it will always give true. So this is supposed to give true and it will always give you true. But when you do d is e, right, print d is e, now you can't be sure it will give true and false, true or false. It can either be true or false. So you can't guarantee this. Why? Because you have crossed the limit of 256. So after you cross the 256, it depends on your computer what you are using, and it depends on circumstances, will it give true and false. So when if your number is greater than 500, you can't, greater than 256, you can't be sure if it will print you true and false, true or false. So here it may give you true. If you see here, it may give you true, but this is not always the case. If you keep on running or doing some other computer or somewhere else, this can in some case give you false. So when you are doing anything, if you are going with an integer, if it's above 256, then just make sure that you are always correcting it, because this can cause a problem in the later on, because this can either be true and false and you have no control over it. So you should always assume that this will give false, or you can't directly assume, and you can't put a condition like it will always give false. So it can give anything. So you need to handle this very properly. So that is the special case about this is operator. And this is the end of all the operator that we wanted to learn. So let's go through it one by one, once again from the top. First is, what are operators? So operator is a special keyword that allows you to perform various operations in variables and values. So what are some of the operators? Plus, minus, equals, and all that, and that we learned and all this. Now what are the various categories? So we can categorize operator in this 5 to 6 groups. We can do arithmetic, we can do comparison, logical, assignment, bitwise, membership, and identity. If you go to arithmetic, arithmetic is all about that what you do in general mathematics: plus, minus, multiplication, division, equals, root, and all that. We have done all of them. And second is comparison. Comparison means when you want to compare between two variables. So those variables can be equal, greater than, not equals to, less than, equals to, and all that. Then comes the logical. Logical is if both of them are true or any one of them are true. So we can do if and or operator using this logical operator. So by default in Python, if a number is equals to 0, that is supposed to be false. So we can do by boolean b equals false, or you can do x equals to 0. They both mean the same thing. Then come assignment. Assignment we have done mostly everywhere. The assignment means when we assign a value to a variable. So we can do addition and subtraction. If you want to do this, if you want to reassign a number, right, by adding something or multiplying something, you can do using this plus, equal, minus, equals, and all that. Do this for your homework and see if you can figure that out. Then come bitwise operator. Bitwise operator is the operation that we do on the bit level. So to find what is a binary or bit of that number, you can use the bin function that will give you the binary. Then we have like AND operator. AND operator is that AND symbol that you use, that is the AND operator. And then we can use this, and I have shown a small table to show like how we are getting that number. So in AND operator, if any one of them are false, the result is false. Then we have the OR operator. So OR operator is a pipe symbol. Then we have XOR operator, that is the power symbol that you use, that is the XOR operation. Then we have left shift and right shift. Left shift means putting one extra bit at the end of the number, and right shift means removing the end bit of a number, that is right shift and left shift. I have shown example of both of them. Go through it, put some other number and see if you are getting the desired output. Then we come membership. This is more useful when we do in a sequence, like if you want to see if a number or value is present in a list or sequence. That is where you can use in. Similarly, you can also use not in. It is just checking if it's not in the list. Okay. Then we come to identity. That is where we use the is operator and double equal. You saw how it's different from double equal, how the is different from double equal. So what does double equal do? It checks if the values are same. But when you use is, it will look for the reference. Are they referencing the same thing? So it will look in the memory location. And there is a special case. If it's below 256, it's always true. Both of the number are referencing the same thing. But above 256, it's an unsure value. So be very careful while dealing with this. So this is the end of it. Now let's push it to GitHub. We'll do git status, and we'll do git add all git commit operators and expressions. Expressions means just it's a mathematical expression, like we are using the operator to form like a format what we wanted, like a plus b, right? This is an expression where you use the operator plus. So that is what expression is. Git commit, let's push it. Git push origin main. Okay, now let's go to this and see, we should be getting it. Now if you go here, you can see operators and expression, and see here we get all of the expression that we wanted. So that was it for today. I hope you understood how operators and expression works. If you are facing any difficulty or you did not understand any topic, put in the comment. I'll see it and I'll reply it one by one, everything. So that was it for today. If you are enjoying it, you can like this library and put it in and rewatch it when you wanted to, and share it with your friends who are learning Python so that it become useful for others. So thanks for watching. See you in the next.